It's live. That's
Hi everyone.
hello. Oh yeah,
How?
it's live now. We have two people watching, three
Okay.
now, but one of them is me. Let me close this screen. Oh yeah.
So let's just kind of wait for 5 minutes before we start.
Oh yeah.
Yeah.
Okay, I forgot my makeup. Let me add a
So to
cool
everyone
picture.
who's watching, Ricardo's a very funny person to talk with. He's
Oh no, that's a
he'll make
lie.
you laugh a lot.
That's a lie. Don't lie. Um, what are we going to talk about again? Uh,
Today we'll be talking about one of the best collaboration tools, which is kind of just mandatory when working in teams, called GitHub. Most of you might have heard about it. So we'll be talking about how you can use GitHub effectively, and also we'll discuss some Git strategies, how to do version control, and things like that.
oh, that's cool. Let me download GitHub then.
So, so what you can do is actually download Git, and which is a VCS, but GitHub. For GitHub, we to work directly with GitHub, you have something called GitHub Desktop, which we'll see, which we'll see in the stream, right?
Oh yeah, I hope we do. Uh, in other words, I can't download GitHub,
Yeah,
right?
you can't download
Yes.
GitHub. It's a website. You download GitHub Desktop.
Oh, I can't download a website.
You can download a website, but uh, let's say in a workable format, to get all of the capabilities, you go to github.com to try it out for yourself.
Okay. How do I open a website? Just kidding. All right. So yeah, we have more people joining. So welcome, people. Um, we have Manish has said hello. Hello, Manish. So yeah, I'm sending the reminder for other people on Teams as well. As soon as I find the thing where I wrote this. I'm kind of confused. Most of the times I type stuff, I don't remember where I did. Uh, I guess. Oh, that's because, yeah, here it is. It was on the most obvious place. Brings that ninja up my friends. Okay.
So for people who are just joining, we'll be starting in kind of 2 to 3 minutes,
Oh
just
yeah.
waiting for people to come in. Till
Yeah.
that time, you can put just like kind of introduce yourself in the chat. We are seeing the chat constantly.
Oh yeah. Um, I just got another response for the form. Ooh, cool. Okay. What do I have in my? Oh no, no, not this. No. Oops.
So let's start now.
Yeah, we
Or
can start.
yeah. So hi everyone. I'm Rishabh Tavli, and um, I am a 10th grade student and a past TEDx and TEDx speaker. I'm also an AI and Android enthusiast and a Google certified mobile site developer too. And I've often represented India in international level hackathons and competitions, and also won a few of them. Um, Apart of that, I love to conduct research. Research is what I love the most. So I've also written 7 research papers, and you can find me on any of these links. Just ping me, and I'll be more than happy to talk with you. So you can just ping me on any of these URLs.
Oh, yeah. And I am not a 10th grade student, but I'm cool too. I am a billionaire. I am a inventor. I have invented a giant armor, and you probably have seen one of my movies. I'm called Iron Man. Just kidding. I'm not Iron Man. So yeah, I'm into computer stuff as well, and I'm a Microsoft student partner, and this is going to change name soon to student. It's Mercer.
Learn
Student learn,
ambassadors.
student ambassador, student learn ambassador, ambassador learn student, something like that. But it's cool anyways. You can Google and the right name will be there. Anyway, we'll be talking today about, I think Rishit said briefly, we will be talking about Git, GitHub and version control systems and how it can actually be a good tool for us. And I think we have a very wide public. The slide there was showing it. We can have a lot of people can be benefiting from that. Briefly, what we expect to talk, and we hope we're successful on doing that, we'll be explaining why should we use version control tools. We'll be covering what is Git, what is GitHub, some basic concepts. Hey Ganesh, welcome. We'll be talking about GitHub Desktop as well. It's an amazing tool. We'll be showing the power of the integration between GitHub Desktop and Visual Studio Code. We have some code reviews templates. What are code review templates? Anyway, we'll be getting to that part.
Yeah.
And what next? Because we have a lot of other stuff we expect to cover as well as a Q&A session. And yeah, so yeah, why should we use and what is a version control system?
Yeah, that's like the first question you'll have when you start programming, because what I do, I just hit control s, and I'm done. I email files to my peer, and that's the starting thing of what we do, right? So let me tell you why you would use version control, or what's the motivation behind having a version control system at all. So let's say you have a product which your team is working on. For now, let's say you have 4 people, and oh, I know there is a fifth one over there, but I just made it a fifth person as I thought he would be a manager or something like that. But you are a group of 4 people. You are a group. You are a team of 4 people, and your team decides to add a feature to the product. So the rocket thingy which you see over here is your product, and your team decides to add a feature to the product. So so the next ideal step would be your team works towards it, and you add the feature successfully. You're now happy with your progress too. But there's another problem, uh, which is you suddenly experience a huge demand for your product. This is something good, surely something good for your company, something good for your product, but you surely need to make some changes, right? In the way you handle your users or provide services to your users to now accommodate all of the new users. So now your team and you have a new task, updating your infrastructure or writing code in a manner that you can accommodate all of these additional users. Now, this isn't actually a very large problem if if your company uses cloud-based systems, or in this example, the company uses cloud-based systems. But for this example, we'll just take example of a small on-premise company which has all of its servers on-premise. We'll just take an example of it uh, to serve as an example for us. So each person from your team handles different aspect of making this modification to allow your product to reach more people. Let's say you make a change called change A, your teammate makes a change called change B. While combining the work, both you all did, you have conflicts. He made some change on line 120 maybe, you made some change on line 120, and now while merging your code to become ready for industry level production, put it out into production, you face a lot of conflicts. So maybe he made changes in some file A, you made changes in some file B and file A. While merging it, you skip one part of the code and the other does not work well, and things like that. And you, of course, have conflicts in concurrent pieces of code, and you have incompatible changes. So you can so then you, what normally teams do in these kind of situations is they share code with each other in something like final code, final code, super final code, and things like that. You might have done that too, right?
Oh no, I never did that. No.
Oh, because you know about version control.
Oh no, my codes are always perfect. They always work.
That's a pretty ideal scenario.
Ye- oh yeah, no, because I'm a genius, like from
Oh
the
wow.
movies. Yeah. So yeah, my codes are always perfect.
So moving on, in this scenario, your code base is too messy. You have all of these different files, and you have almost no flexibility so as to what I want to do. Also, tomorrow when you maybe realize, oh, I made a mistake in the code, I just want to go back. I don't want to have all of these changes. I think I made a huge mistake. There's no way for you to do this too. So many problems. Version control systems help you in solving all of these problems very simply, and we'll be taking a tour today itself. So there are majorly two kinds of widely used VCS or version control systems called distributed and central VCS. So what distributed VCS means is you have multiple code bases, and each developer has his own version or has his own working copy instead of having a central system where you make all the changes. So we'll be talking more about the distributed VCS today due to a lot of its advantages. And Git is a distributed VCS too. So let's see what Git would give you. So you would have a change log for all files. So maybe you encounter a bug, something you didn't want to do. You can go back to any particular change. We'll see how do you go back and things like that. But you can go back to any particular change you have made. So you can find the root cause of a bug very easily. And of course, that helps you, so gives you the ability to solve bugs too. With the ability to go back to any point in the change log, Git also provides you a way to see who was the author who made the change, the date on which he made the change, and also a short note explaining the change. So when you're working in teams, this is really helpful. You know, okay, maybe Ricardo made a change on this day and he writes a comment explaining this is why I made the change. Again, easy for us to find bugs. We'll discuss branching and merging in great detail in some time. For now, you could understand it as a way to easily fix the conflicts we talked about. Developers making different changes and then trying to merge them into the code base. So that was about Git, about version control systems. We also saw big Git lies. It's a distributed version control system. So I talked about version control systems and Git, but there's a website called github.com. You might have visited it. So how does that align to Git and how is it different from Git? Maybe Ricardo, you could tell others about it.
All right. Yeah, I'll try to tell some differences. And this is really funny because sometimes you talk to people and there's a very common misconception. And people think that Git and GitHub are the same thing, but they're not. So, although that image there shows a battle, they're not fighting against each other. They are complementary things. They play nice together. Git stands alone. Without GitHub as a version control system or a VCS, you can say VCS to look cool and look smart. So when we develop software, just as Rishit was explaining, we'll reach some points where the software will actually do the result that we expect it to do, and then sometimes it won't work the way we expect it to. And Git will allow us to memorize these points where our code works so that we can easily return to them. Let's say, for example, I have a game and then I have my 1.0 version works just fine, but then I want to add a feature. And then I add this feature and it completely messes up my game. So when you're using a VCS, you can just easily revert the changes that you've made. Anyway, there are several good points to do, as Rishit very well explained. But what's the difference between Git and GitHub? In a short version response, Git is a VCS that tracks your changes when working with electronic media like software applications, even text. GitHub is a repository. It's like an online storage room for this media, and that's it. GitHub pros may say that, oh no, GitHub does this, GitHub does that. But basically, GitHub is just a file cabinet, online file cabinet in a website. And then, of course, it has more functionality. We'll be explaining about additional functionality, but summarizing it fairly shortly, that's what GitHub is.
Yeah.
Uh, I think I explained it. I hope I explained it well. And if you don't understand, that means you're dumb because I'm a genius. Uh,
Okay. Let us know if you have any questions in the comment. So I think Ricardo, you explained it wonderfully. The difference between Git and GitHub. You essentially told what it is about. So uh, now we'll come to some of the Git concepts and how you can make the best use of it and make the optimal use of it. Share your code with others. You'll also see how you can contribute to open source projects or how to make an open source project. Allow people to contribute to your project. So, and I love demos. So we'll be seeing all we talk about in action too. We'll be trying out all of that uh, for ourselves right over here. So this is the repository for the code, which I'll be using, all the demos I'll be doing, and all of that. So you can go to this URL, browse to this URL. You'll find all of the code I'll be using, all of the commands and the code I'll be using. So what I'll do is I'll give you a moment to make a note of this URL.
Ooh,
Okay,
there's a
so
link.
yeah, uh, yeah, that was a link. Maybe you made a note of it now. So Ricardo said something while explaining Git versus GitHub repository. So we'll start talking about with repository. The first thing you'll be doing, the first thing you need to know. So your repository is simply the code base or just all of your code with the Git specific files. So you have versions of your code base, the change log, and all of it, which we'll see soon what Git provides you. You have all of that in the repository too. So you can make your code folder as a Git repository simply using this command called git init, and we'll soon see this in action. But this is a simple command to uh, make your repository a Git repository, saying I need all changes to be tracked. I need everything. I need all of the Git functionality in this folder, which would essentially be my code folder. So now let's say you make an application which connects to a server. If you want to make this an open source project, or you have to collaborate with people who you don't want to share your server credentials with. Let's say it's an API key or something like that, which you don't want to share it with other people. Or if you're using Firebase, it could just be the Firebase JSONs or RC files. So again, this is just a simple use case to make you understand. In fact, it could be anything. Server credentials is again just an example. Git does not track all changes in all files for you. You need to add a file, or maybe you can add even a folder to be tracked. Saying, so now you are saying, okay, Git, I give you a task. You need to record all changes which I make in this particular file or in this particular folder. So that's what tracking and untracking means. So how do you add a file to be tracked? You simply use the git add command. So when I do git add followed by a file name, I'm just telling git to go on and start tracking the file, meaning having a change log and all of that for the file. So you add your code file to be tracked. And let's say you make a change to the code file. You add some code, you save it, you made a change to the code file. The code changes you just made are in something called as a staging area. So what this means is you change the file which was being tracked. Okay, so Git knows, okay, I have to maintain a change log of this. So you change the file which was being tracked by Git, but you did not yet add a record of it in the change log or the version history. So I made a change, but I did not yet add it to my version history. Now, of course, you do not need to manually go and edit the version history or the change log maintained by Git, but you know what I mean by staging area and unstaging area. So let's go ahead and see this in action now. So all that we talked about, Git init, Git add, let's see them in action now. Okay, so there's this. I told you Ricardo is a funny man to be around. He'll make you laugh a lot. So this subscribe thing which you see down here is a hoax, not true.
Oh, really? Oh,
Yeah,
people
really.
are going to be angry because I have like 30,000 subscribers now.
Okay, so I have a command line over here. Um, yeah, I'm not using my local system. I don't trust my local system, especially when doing demos. So I don't use my local system while doing demos. Let's go ahead and try out everything. So I'll make a directory which I'll call, um, yeah, I'll make a directory which I'll call repo demo. So we talked about repositories. So I have this repo demo over here. So let's go ahead and I'll do git init. So what I did was I initialized an empty git repository, of course, because my repo demo is empty in um in in the folder called repo minus demo. So let's go ahead and add a sample file over here. I'll call this, I love nano by the way. Yeah, so I'll call this nano hello.python. I love Python too. Hello.py. So let's go ahead and add a random, yeah, let's go ahead and add a random bunch of code in it. Hello world, and save this out. So now, when I do git status, you do not need to know what this is, but I'll just see I have no commits yet, or you'll see what commits are and how to make them. But for now, I have nothing written in the version in the change history, and I can see untracked files over here. Hello.py, the file which I just made, is untracked. So how do I add it to be tracked? Well, here's how you do it. Git add and followed by the file name. So I've now added hello.py as to be tracked. Now when I go ahead and do git status, which just shows me the status of everything, the commits I made, and things like that, I can see it's now tracking hello.py. It says it's a change to be committed, which means it is in the staging area.
I have
I
a question.
added, yeah,
I-
go ahead.
Uh, what is this nano thing you typed?
Oh, so yeah, um, Nano is just a text editor. So I'll go ahead and do, which is inbuilt with Linux. So I'll just go ahead and do nano hello.py. So I can see this short, like it's not too good, but does the work. If you want to type small things, it's just a text editor. So I can edit, so I can put in this print hello world inside my hello.py file.
So it's like Word.
Yeah, a mini word I would say. Doesn't
Okay.
have all the features, but yeah.
Yeah, but do I have it in my computer?
If you are using Linux, you have it. You most probably have it if you are using
Oh,
Linux.
okay. So if I'm using Windows, how would I do it?
So on so let's say if you are using Windows, um, a simple thing would be you
Shooting
can,
my, yeah, I can shoot myself in the head, right? No, just kidding.
yeah. So yeah, if you're using Windows, you can just go. As this is for testing purpose, of course, in a real life scenario, you would use an IDE where you code everything to add it. But if you want to replicate this demo for Windows, you'd maybe just open it in Notepad, which again comes pre-installed with Windows. So you can open it in Notepad, add print hello world. So um, yeah, almost the same. Linux comes built in with Nano. Yeah, Windows doesn't come built in with it. So you'll have to open it in a notepad.
In other words, Git is so cool that it works in Linux, Windows. Does it work for Mac as well?
Yeah, it works for Mac too. On
Oh, cool.
Mac, I think you have this inbuilt command called touch, which makes a file, and then you can just go. I've never used Mac, but it has this inbuilt command called touch, and then you can and then you can start editing it in a normal text editor.
Oh, cool. So, yeah, we even have a comment here on chat telling us that for those who use Windows, you can use REPL.
Oh, Ripple, right?
Yes.
Yeah, Ripple, you can start doing things in you can start doing things online, so you don't actually need to have the all of. So I have Git installed and things like that on Ripple. You can try all of this online, so yeah, that's a good way to do too. Okay, so let's continue off with this demo. Let's. Give me a sec. I'm sharing my screen. Here it
Yeah,
is.
your second is over.
Now I've shared the screen.
You should be
Okay.
faster. You said 1 second, but you took like 5.
Okay.
You're not doing
Sorry.
your job well. If you're watching this, he didn't prepare.
All right. I prepared it.
Okay,
Bye.
so yeah, let's go ahead. Oh, animations. Okay, so our presentation is so cool that it has an animation.
Yeah. So I had my files in the staging area. Whenever I changed them, and so whenever I changed them, they came into the staging area. Now, as I like to explain you, now you want to add it to the change log. I don't want to be there in the staging area. I want to add it to the change log. So you commit your changes. Another thing to know back when I said is you can with a version control system, you can go back to any change you have made. What I meant to say at that time was you can go back to any commit you have made. So ideally, what you do is every time you make a change in your file, whether it works or it does not work, you make a comment.
Okay, a commit, so it's not like a comment.
Yeah,
So
it's not like a comment.
so a commit is like sending the file somewhere, right?
Yeah, or maybe you do not even send it to somewhere. If you're using Git on your laptops, you do not you have it right there on your system, and you send it only when you do a push, which we'll discuss. But
Okay.
if you're on the GitHub UI and you do a commit, you essentially send it to the main code base.
Oh, okay.
So yeah, you can go back to any particular commit with Git. So another thing to know is you should not pack everything into a single commit. Uh, you should do commits for small changes. Let's say if you made a lot of changes to add a feature, do not pack all of these changes. Maybe you made 500 additions and changed 20-30 files. Do not pack all of these into a single commit, because let's say it will defy the purpose of Git. We just discussed making bugs easier to track. If you pack everything into a single commit, you'd just be able to go back where you started from scratch before making that commit. So you should ideally not pack everything into one commit. Make small changes and pack them into commits. So whenever tomorrow I say I want to go back to any particular commit, I can easily do that and find the causes of my bug. So also another thing is I earlier said that you have a change log with explanations for each change, which was really cool because I'm a developer. A peer wrote the code. I don't know what he did and why he made the change. That's a huge problem. It's why comments were there in the first place. Understand the code. but I do not want to go into intricacies, which happens most of the time. I'll just see why he made a particular change. So, how do you do this? Uh, Commit messages. So, every time you commit your code, you have the ability to add an explanation for those changes. We'll later see what convention you should follow, optionally with a message subject. So you can also have longer descriptions explaining the change in detail. So I have, just like how you send an email, you have a subject which shows what you say in the email in a single line, and then you have the description of the email which elaborates on it. So you can have like a subject and a kind of um, explanation for it. So the root command is git commit, and you have an command line argument minus m, which allows you to add the subject. We'll see how you can add the explanation while we do the demos part, and I'll also tell you a few good tips for writing these comments. Another important thing to know about is remote. So it is simply a Git repository which is not on your machine. So uh, so maybe it could be on GitHub, or uh, so what you want to do is tell Git that whenever I make changes, or whenever I say, okay, I want to push all the changes I made to to be reflected in the common GitHub repo. So my peers or the people who are working with me on developing that code will see that GitHub repository as the common code base between all of them. And I can just say, and that is a remote repository for me, and I can just tell Git, okay, I want to send all of my changes to that remote repository. So what will you do to enable this is add a remote repository. I will add a remote repository from a URL, which would be your GitHub repo most probably, and I will give it some name. We'll soon see how this name part helps you and how it makes things a lot easier. So uh, there's another cool argument called minus v, which I thought you should know about, and it will show you all the names and the URLs which you have added as your remotes. So just anytime you're confused about what did I add, you can just do a git remote minus v. So once that's done, you will of course commit your changes. So I want them to be added in change log. I'll of course commit my changes. You'll then use the push command to send all the changes you made, all the commits to all the commits are specific to the to the specific online code repository. So maybe again it's maybe a GitHub repository, and you push all of your changes in there. So that was a lot of talking. Let's get to the demos part again. So I'll just switch my screen and uh, add it to, let's do an entire screen now. Yeah. Okay. So maybe you can see my screen now. I have this repository made, which is like a blank repository just to test things out for you. And I just made this right. Oh, yeah, here it is. So another thing I want to tell you is we had this effective GitHub training repository, and we have all the demos we'll be covering in this particular session right over here. So we have this initialized repository demo. So just go to the, let's just try out the commit. Let's just try out the, let's just try out a remote repository demo. So we'll essentially follow the same steps, but yeah. Let's go back to my terminal and I'll make a directory called test2 or my demo2 as you would like to say. Let's go into test2. With the usual steps, I'll do, oh, got in it. Sorry, git in it. So the usual steps, I made an empty git repository over here. Let's add a simple file to it. So to save some time, I have simple commands which I want listed over here. So I'll just make a README file, so I don't have to kind of type everything. ls. I have a README file made with me right over here. Let's see what this README file has. Yeah, like yeah, of course, yeah, it has this thing. So that's just a simple README file I made, and what we'll now do is we'll add it. So I'll just do. Oh, sorry, typos. I hate them. I'll just do a git add, and then I'll just do a git commit. Now this is the part I want you to see. Okay, so here's how you send your message subject. I'll add in the message object, I'll add something like added readme.md or made a readme. So leaving a line, I'll I'll add my in detail explanation about it. So I'll just add made a sample readme with some text for testing. Like this, and this will be my commit message and my commit explanation. So let's go ahead, and I want to save this. Yeah. Okay. So so now I have it committed. What I want to do is I want to push it to the remote repository so I can see my changes reflected over there. So I'll just do a git push. So okay, let's do another thing now. I'll just do a git remote minus v first. So as you can see, I have no remote repositories configured. So let's go ahead and do this first. So I'll just add, a new remote repository. So I'll just do git remote add, give it a name. Let's give it origin as a name. And I'll just copy paste this one over here, which is my GitHub repository URL. Git remote add origin. So I've added a remote repository named origin, and I'll just do a push now. So push I'll just push it. And what I'm saying is you push the main code or the root code I have over here to the remote repository. So
Okay,
I
I have a question.
yeah.
Uh, you typed in origin, but can I use any name?
Yeah, you're free to use any name. So you
Okay.
can even make you can make names. A lot of times people end up using their own names, saying that okay, for easier transparency, saying that okay, I'll just push out my version. So maybe I have git remote add Rishit, and I'll just push out my version. I don't know why, but a lot of people feel that's comfortable. So I just pushed all of the changes I had to origin,
So
which
yeah,
was this
if a person is named origin, then
one.
that would be
Then he
curious.
uses the exact same command.
Yeah.
That was a good one, but so I'll just refresh this. Okay, we have this testing right over here, and I just added this as a remote repository, pushed all of these changes to GitHub, and I have it reflected right over here. And what is also cool is let's go to comments. Yeah, here's comments. I can see who made this change. it's Richard Dudley or me. I just made this change right in front of you. So I can know, okay, this author made this change. That's again something cool, which person made the change. So let me quickly switch my screen back again. You just saw how you can use remote repositories, and how you can commit to how you can push your code to remote repositories, and allow people all over the world to take a look at it. So so we'll talk about the next concept, which is branches. Now, branches is again something really cool to know, as it allows, as it's almost mandatory to use. So we'll see what branches are and how they help us. So let's get started with the branches part. Just a sec. I feel there's some lag over here. Okay, yeah, it's good now. So uh, so now I have a repository, as we just discussed, and if I see its history, I have a linear commit history. So those circles are commits, and meaning each time I hit commit, I have this list expand, and each commit has an unique identifier with it. So you can go back to any commit. Every commit has this unique identifier. So now one day, maybe your friend, or in this example, let's say Ricardo tells me and says, why not add this feature? But I'm not completely sure if Ricardo suggested me the right feature. So I just want to try it and have it like
Oh,
an experiment with me.
what do you mean? Are you telling me that I send wrong features?
Oh, I challenge that. I may not be the right person to code it properly.
Ah.
So what I want to do is branch off my code or make a copy of my code at this particular point and experiment on it. So this is what is called the master branch, or my main branch, also called the root branch. So it's by default name master, but again you can change it to anything. You can change the name master, but if you don't make any changes, by default it's called the master branch. And I can continue my development on this copy or on this branch. And anytime I just feel, okay, I need a change to be made in the master branch or my root branch, I can just switch my branch and make a change over there. So I can easily switch back and forth between these branches too. Oh, sorry. Yeah. I just kept a slide. Sorry. So I can also create new branches from the master, or create branches on a branch itself. So this might get a bit complex, but if we I have this branch and I can create a branch off from it too. So, but for now, for this example, let's keep it simple. Let's just say I have this short history. So I feel that I did a good job. The feature was up to the mark. It was a good feature. So I now want to merge it into my root code. So
Okay,
I make yeah,
I have a question. So
yeah,
let's say we're running a project with 100 people coding.
yeah.
So in this case, each person should work in a branch in order to make it easier for the person who's managing it to see who's working on which part, or how do that work? How does that work? Does every person has to be a branch in a code?
No. So what you can do is maybe I get a task. You improve a feature called feature A in my product. So what do I do while I try to improve my feature A is I have the master branch, which is my production code. I don't do any changes to it. As we all know, if you make any changes to code, it usually tends to not work. Happens a lot with developers. So yeah, so while adding feature A, and doing all of those experimenting stuffs which I need to add feature A. Maybe I use Stack Overflow answer one at the first attempt, then I go on to the second answer of Stack Overflow and add that bit of code while I try to make it work. I should do all of this experimentation stuff in a new branch. So it's so you should have branches according to the kind of experimentation work you are doing. It should not be something, it could be, but it should not be something like I have my branch where I do all of my experimentation work. Instead, it would be better if I had a bunch of people working on a branch, which is, and the aim of this branch is to add a feature called feature A to my code. I think uh, that kind of makes up for it. How you
Mm-hmm.
should have branches. Yeah. So what I'll do is after I branch off and I am now satisfied with my code, I make a request. So uh, okay, so I make a request to it to merge my changes into the master branch, which is called a pull request. So I have the changes I made in the new branch reflected back in the master branch, as I'm now satisfied that my new branch is good enough. The cool thing is you don't actually overwrite all of the code. So I don't do something like I take in the code from from this other branch and put it on top and erase everything in master branch, put the code I received from the other branch over there. I don't do that. So as I said, Git keeps track of all these changes, and with a pull request you're essentially telling them what change you made and not sending the entire code. So you of course send the entire code, but you don't want entire code to be copied and pasted over there. You want your changes to be reflected, which is something cool. uh, let's see why is this so. So my master branch has this file called hello world.py, which simply prints out hello world, nothing rocket science, nothing too great. So uh, you create a branch from this, which is another type of greeting called hola, and add a code file in it which prints out hola. So in the master branch, let's say I create one more file which is called more greetings. Now I created this branch called hola back when I had just one branch, just one code file in the master branch. So the file called more greetings.p is not there in my other branch. So this more greetings.p is not there in my hola branch. So when I go ahead and make a pull request, Git is smart enough to look for changes. So I'll face no problems. I can easily merge them. So I can easily merge these two branches to give me something like this. My master branch with all three of these code files. So again, Git just tracked all of these changes for me and did not just kind of dump the source code. So let's see a demo of this. For this one, we'll see how you can use GitHub itself, the GitHub UI. We talked a lot about Git CLI or command line, the command line interface of Git. It is also very important to know how you can use the GitHub website too. So we'll see how you can do this in GitHub website, and it's really straightforward. It's exactly almost the same thing while doing it in Git CLI. So let's see a quick demo of this, and again I'll just switch my screens. So I'll do. Okay, give me a sec. Yeah, here it is. Yeah, this was it. Yeah. So this is again another repo I set up for testing this out. So let's go ahead and make a new file, in the master branch. So this is my master branch or my root branch. So I also want to show you, you can make files directly here in GitHub itself. Uh, but as and you should, and you would not always prefer this. Of course, you have no syntax thing, you have no compilation things, but this is just a small code, and I'm sure this works. I'm confident of myself, at least that much. So I can just put it, print hello world. Okay, let's just I'll leave the comment messages because I'm just trying to show you a demo over here. So I have this hello world.p. So let's see, how do you create branches in the GitHub UI? I can go over here and let's create a new. Okay, so patch one is occupied, and just forget about it. Just me trying to work around things. I'll make a new branch called patch 2. So now I'll go to the patch 2 branch, and I can see my patch 2 branches even with the master. So I have the exact same copy of code which I have in master in my patch 2 branch. So now my patch 2 branch has it from the master. I'll go back again to the master, make a new file, which we'll call hola.py. Yeah. So let's call it hola.p. And I'll just do print hello. Okay. So this was more greetings, right? I just forgot the name. Forgive me. So how are you doing? And I'll comment this. Oh, it got zoomed in at too. Yeah. Yeah. So I just commented that now, and what I'll do now is I'll go to my patch 2 branch, which is over here, and I see that um, this branch is one commit behind the master. So a part of which is because I added the file more greetings. I'll create a new file which I'll call hola.p, as we saw in the slides, and I'll just print out hola. So this is just for demo. Simple. I'm using simple files now for just for demo. So I can see now. I'll do a compare and pull request. So I can see um, I'll do create hola greeting as a pull request. So I'm making a request to merge these changes into the master branch. So here's my request. So what I want you to do is forget about this part, CI and GitHub Actions. We'll cover that in a later part. I can see this branch has no conflicts, which means Git has automatically done all of the heavy lifting work for us. I'll just merge this and let's see what we get in the master branch. So no time in the master branch. I just merge the code, and when I come over here, I see these three files. So I also see the hola.p file, which I got from a pull request I made from this branch called patch 2. And I also got this more greetings file, which I made in the master branch. So Git just tracked those changes for me and brought in the hola file. That's something cool. What I also want you to see is Git has this wonderful thing when you go into insights, something called network. Where's network? Yeah, here's network. I want you to look. Okay, so forget about this. This is just me trying to do some experiments. Let me zoom in. Yeah. So what I want you to look is at this part of the code. I can Git also provides me a GUI kind of interface. So at this part, I created hello world, and I made a copy of it in a branch called patch 2. I made a commit in my master branch, and then I merged both of these patches. So this is how you interpret these kind of graphs. So that is again something like a cool GUI visualization that GitHub gives you. Okay, so let me again just switch my screen. Oh, yeah, yeah, I'm sharing my screen now, and maybe you can see it too. So now you saw how smart Git was. It handled all errors for you. Oh, before we define all errors, but sometimes you can run into problems. So even with Git being so smart, you can run into problems. So when do you run into these problems or conflicts? When you change the exact same line of code and try to merge it, or when a file has been deleted in one branch but edited in another one. Again, Git has you covered. Let us discuss how you can proceed in case of conflicts. You can use Git merge tool, which provides you an easy way to take a look at these conflicts. I feel let's do this in a demo itself. I'll be using GitHub UI to show you how you could use how you could use GitHub to resolve merge conflicts. Process is again exactly the same in Git CLI. You get the exact same interface. Nothing is different. I also want you just to know we did two demos in the Git CLI, so two demos in the GitHub UI too. So I'll again switch my screen, and yeah, I'll switch my screen over here. Use it. Yeah. Yeah. Which one was it? Yeah, this one. Back to the same repository which I just made. What I'll do is I'll create a new branch. I'll branch off from this, which I'll call patch 3. Create branch patch 3. So I have this new branch where I say I want to change hello world to something with quotes, and I commit this as a new branch in the patch 3 branch. What I do is I go ahead and change the exact same line of code in my master branch.
Hey, shit,
In case,
that's me calling. You don't need to pick up.
okay, yeah. So, uh, so just in case it happens, you change the exact same line of code. A developer goes ahead and changes the exact same line of code called Hola World. So I have changed this exact same line of code, and let's make a pull request now. See what, okay, yeah, here's a patch 3, and I just added updated hello world.
That's
So
not me.
yeah, I know, just some background noise. So okay, what do I see here? I have a conflict. Yeah. So uh, uh, that happens because I changed the exact same line of code in both of the in both branches, and now I'm trying to merge them. So GitHub or Git, for that matter of fact, is confused. So let's go ahead and try to resolve conflicts. I'll show you how you can resolve conflicts. Use it to resolve conflicts. So you need to make sure that um, everything. So this red part is the part where it is facing conflicts. I just have one conflicting file, so one file name listed down here. So I see in patch 3 I have hello world with double quotes. In master branch I have hello world with a single quote. So now I want to resolve this conflict. So let's say I don't like Hola World, I like Hello World with double quotes. So what I'll do is First, I'll remove all of these uh, naming patterns. I don't want them. So, and then I'll remove this part. So I just want hello world with double quotes. So once I have that done, I'll just go ahead and mark it as resolved. Then I can go ahead and get it merged. So I just showed you how you can resolve a conflict. So what? Now I have no conflicts left with the page branch. Let's go ahead and merge the pull request.
So, in other words, if you want to solve a pull request between multiple branches, you would have to edit all files or just edit a final version for the files.
Yeah. That's actually something good that he asked. Something thoughtful. So what you would have to do is you would just have to kind of uh, so let's say I'll put in. So let's say two files have a merge conflict. I'll just change the things I want in those two files while I click that resolve conflict button. I'll just change the things I want and I remove the things I don't want. Where GitHub shows me that red colored highlighted thing, I'll just go there, change the things I want, remove the things I don't want, and mark it as a resolved conflict. So I'll have to go ahead and manually do this part for all the files which have conflicts, but only for the files which have conflicts because I change things on the same line, right? So of course you would have to do it manually then.
Okay.
So now I can see I have hello world with double exclamation marks right over here. I showed you how you can merge your conflict, choose hello world with exclamation marks rather than hola world. So that was for this demo. And let me share my screen again. Yeah. So we talked a lot about Git CLI and a bit about GitHub UI, only the parts where it was similar to the Git CLI. What is also important is a wonderful tool called GitHub Desktop. Ricardo, could you tell others about how to use this wonderful tool, how to harness the power of it?
Oh yeah, for sure. Uh, so the first thing, GitHub Desktop, unlike GitHub, which is a website, GitHub Desktop is a software. So we download it, and I've even added a simple explanation here. You type in the address, which is like a, a text that corresponds to a page. You go up there and then you type it, and then boom, this page pops up, and then you click that button if you have Windows. And if you have something else, you can choose whatever else you have and download it to it. I don't think GitHub Desktop is available for Linux, unfortunately. I think it's only for Mac or Windows. Am I correct? I'm not sure.
Oh, I've never tried it to use on Linux too. I've always used the command CLI for Linux. I've never tried it. I don't think it's there for Linux. Um, yeah, I don't think it's there for Linux. I've never
Oh,
tried it though.
so we have a problem here. So which one should we choose? Command line interface or a graphic units interface? So should we use the commands to look cool? Black screen, green types, just like the Matrix movie? Or should we use a GUI? It's funny because I think it was 2 years ago. I'm not sure if you guys know the website called dev.2.
Yeah, I have that too.
Yeah.
Wonderful website.
So Ben Halpern, which is the guy who created dev.2, he tweeted something that saying that even if you like CLI, GUI is cool as well. And he got bombarded with like thousands of tweets of people saying bad stuff to him, people supporting his thing. And this is a very interesting question. Nowadays, GUIs can do pretty much everything that a CLI does. And there's a type of shaming, bad shaming. It's like a GUI shaming, and people that say that, oh, GUI is for people who don't want to invest time and effort in trying to find out how something really works, or even like some people say, no, if you do this, if you use this, you'll never learn how to truly code something or whatever. Anyway, uh, personally, I use CLI most of the times, command line interfaces, but I have GUIs for testing as well, and they're pretty much like even. You can do everything today that you do with a command line. You can do it in a graphics interface. We have several different ones. You have GitHub Desktop. You have some other versions like Git Kraken and some others. But the tools available today are very good. So the question between which one to choose, you can choose any. If you feel better working with a graphics unit interface, you go ahead and do that. If you feel better working with a command line, go ahead and do that. And if you're just used to one or another, just stick to it, and that's fine. I mean,
Yeah,
it shouldn't be an issue. But let's go ahead and show how to work with GitHub Desktop and some of the very cool stuff that we do with it. So yeah, let me share my screen now.
yeah,
Okay. Okay. Let me share this screen here. All right. So I have this
yeah.
cool
It's
guy called Rishit. He created a repo called Effective GitHub Training, and I've looked at it, and I want to work with it. And then I recall someone telling me that, oh, if you want to work with a repo, you uh, just a second. Give me 2 seconds here.
okay.
You can use this moment to do some advertisement.
Advertisement. Okay. So what you can, so just go to this repo, effective GitHub training. It's at bit.ly effective minus GitHub minus training, or you can just take a look at this URL on the top over here, and yeah, try to go around the README. We have tried to include a lot of stuff, how to do continuous integration, how to use GitHub Actions, how to use Azure pipelines, and we'll be explaining all of that to you in a great detail in maybe the version 2 or the part 2 of this stream. But yeah, we have included a lot of that stuff in this repo over here, and you can take a look at it. Um, and we also have the demos right over there. So yeah, it would be worth a look. Try try to what's Ricardo doing? So try to take a look at it, and yeah, have fun walking around with the repo. Yeah, we also have some DevOps stuff right in there. How you can leverage DevOps plus GitHub to create wonderful, cool stuff. Yeah, and uh, just go around the repo. We also have things about running cron jobs and things like that. So you can try it around the repo. Okay, Ricardo, over to you.
Yes, I'm back. So, I was telling that this guy, this cool guy, created this thing, and someone told me, if you wanna work at a repo, first you have to clone it. And then I open this, and the first thing that I see is a green button because colors are nice. So this button says clone, and then I'll just go ahead and click, and then it says open in desktop. Ooh, cool. So I can clone it and use it in GitHub desktop. So I go ahead and I click this button. And then it asks me, do you want to open this application? And then I say yes, because I trust in all the pop-up screens that pop up in my computer. So now,
It takes a moment, maybe.
yes, no, it's just me sharing a different
Oh,
screen. Oh, there
okay.
we are again. And then it asks me, repository URL or GitHub username and repository, and it automatically fills this field. If you're doing this directly, it won't do it. If you're just opening GitHub desktop, you have to copy the address and put it here. And then local path, you have the option to choose to which folder you will download your version of it. And then I say clone, and then it says cloning, and then it cloned. Oh wow, this is amazing. So this is GitHub Desktop. And here you can basically see if you have changes to the file in this place that I'm moving my cursor here. You can commit changes that the program detects here. You just write down the title for the commit. Here you can describe it if you want. You can add co-authors. You can see the history. Oh, see, looks how cool. I can even see what Rishit did and when he did it. So he started working it on June 4, and then he added stuff until here 1 hour ago. So you see how he changed it anyway. So, and even here on the top, I can see the thing that he said. So this commit can be identified by this weird code here, whatever, and you can have a full control of a repository using this. Anyway, I want to show how to integrate with Visual Studio Code as well. So here, can you move to the next slide just real quick?
Yeah, I am on the next slide. Yeah, so I feel VS Code plus GitHub is real cool because all of us use VS Code, right? It's one of the best IDs. So, Ricardo, could you tell us what GitHub plus VS Code can do? Real cool stuff.
Oh yeah, for sure. Um, but before that, you said a Visual Studio Code is an IDE. So what is an IDE? Aha, I'm testing you.
Okay, so IDE is basically a program or software where you have a way to work with or write your code, compile your code, test your code, do everything which is in the development process.
That's a good answer. So let's go back here and let's continue from where I was at. So here, I want to open the repository in my external editor, and then I can select it in options. But it automatically here, for me, it pops up open in Visual Studio Code, which is VS Code. So I click open. And then let me share the other screen. Oh, there it it is. And it even says welcome. Ooh, thank you. Okay, so this is VS Code, and I can see that some things are going on here. On the right side, I see like a folder thing, and I can even control whatever's going on. I can access the files, and let's say, let me make a change. I don't like the way he set up the README file.
Okay.
Okay, let me open a preview. I can even see a preview, and I can even split the preview here. Oh, 1 second.
Oh, you wanted to split it, right? Yeah.
Yeah, right. So yeah, I see how it's okay. I think this should be with a capital letter. And then I go ahead here on line 11, and then I change like this. And then I make a change. And notice how something happened here. You see, now I have a blue bar indicating that a change was made to this line. So line 11, which corresponds to this here. And then here's the cool thing. You see here, there's a source control thing that says that there are two pending changes to be made. So there's a change to the project file. There's a change to the build file, probably something that happened while I was typing this. Anyway, I go back to that file here. README, let's save it. So go file and save, or do Control S. And then 3. Another change here, which is the change I just did to the README file. So I want to commit this file. So the first thing I need to do, I need to prepare and do what Rishit said, to add this to the changes, to stage it, to prepare it for a commit. So I click the plus button here, and then bam, it goes to the stage changes thing. And if I want to commit this change, all I have to do is right here, go ahead and type in a message. And I say, typo in readme.md, which is my favorite type of pull request. And then I click the check mark here, which says commit, and then it commits. And then it takes a while, and bam, the stage changes disappeared here. In order to push it, I just click the 3 buttons here, and then just push. Okay, there's a change here. So I can't push. I need to pull first to integrate my changes. So
Yeah.
let's do this. Let's pull, because there were some changes. And then let's try again. Oh my gosh.
Oh, what's
There
he?
were some changes. Oh, of course. Let me change it back to your screen here. Oh no, let me see here what happened.
Yeah.
So I have another branch. Now let me change to my, because I forked it. So let's do this. Okay, 1 second. Let me fix this here.
So I think we might have made some changes um, Like we might have made, I have made some changes exactly when you cloned it. So
Yeah, yeah. I'll just send a pull request you can ignore, and you can just say
yeah,
no, and then I'll commit, and then I'll push two changes. Oh, yeah. I need to do this. Okay, 1 second. Let me rebase this. There.
so while Ricardo does this,
Yeah.
he's trying to um, make a change. But what happened is, uh, while I was showing the demo, I actually changed the file, so it changed while he was cloning it, which created some problems over here.
Yeah. So what we're saying is exactly a merge conflict live. So yeah, what happened is I downloaded a version, he changed it right after I did it, and
Yeah.
now I'm trying to submit a new version with an old file. So let's go ahead and see if this works now. Okay, I know what's going to do this. Okay, push.
Or what we can do is, like,
Yeah, I'm pulling it back from the.
okay,
1 second. Compare on GitHub.
so it might just take some time for Ricardo to kind of fix this error.
Yeah,
So I think we can continue. Should we
yeah. Let's go
continue?
ahead.
Because it's just you need to clone it again, and
Uh huh. Yeah.
audience might have understood the idea. Yeah,
So yeah, continuing then. This is how they work together. We can pretty much download the GitHub desktop, use it to clone and to control all the information you have on your files and stuff. And there are some very, very interesting tools and applications that we're going to uh, be broadcasting in our next session as well. Do you want to talk about a little bit what are we planning for our next section?
yeah, sure. So for the next session or part two of this, we are planning to go right onto the very cool stuff. Now that you have understood the basics of Git and GitHub, you can see the GitHub specific really cool stuff. So what we saw is GitHub repositories can store information, right? So why not host a website right from GitHub? You can do it with GitHub pages. Or how do you do continuous integration, continuous deployment, CI/CD, have CI/CD pipelines running right on your GitHub code? So it's like saying, I have a Python code, I have a repository. Let's go. Let me show you something which is really live, uh, which is which is something really out there. That would kind of make more sense, I feel. And we'll make this pretty quick. We are running out of time now. Yeah. So uh, I hadn't actually planned to show in real life, like in real time. But let's just go ahead and do it. Let's just see it now. Some of the very cool stuff we'll be doing next time. So I'll just go to my project called Make Code Android, which is an open source project hosted by me, just made a few days earlier. Ricardo contributed to. So this is an Android project which I have, and each time I make a commit to the code, what it does is it tries to build the complete Android code right on GitHub. So I face no compute of my own laptop. It does it all on the cloud. I try to build my complete code on the cloud so I know if my code works or does not work. And I also do DevOps part and all the continuous deployment part, run a lot of tests using Azure pipelines. So we'll be seeing how all of these work together. There's also GitHub pages with this. So you can see I have a GitHub page which hosts my documentation. It can pretty much host anything, but for now it's just the documentation of this project. So it hosts this documentation for this project. A website hosted right there from GitHub. So that's just two of the very cool stuff we'll be talking about. We'll also see how you can release applications right here from GitHub and all of and even more cool stuff. Do see how labels work, how pull request assignees work, how you can do code reviews, which is very important stuff in GitHub. We'll see all of this.
So, do you think we can prepare a hands-on approach for those who want to like do it and work together with us while we're doing the presentation?
Yeah, we can surely work something on that. And yeah, let's try to do it something in a hands-on manner, so, for the next part, so that people can try it while we are doing the presentation too.
Okay,
Maybe quite
and
a challenge, but I'm up for it.
yeah, and for the my final question is, what would be the recommendation that you give for a person that wants to start practicing on GitHub? What would you do?
Take open source projects and try to work on them. So all the concepts we discussed about today, you need to try them on a real repository which is out there. Try to make a pull request to any open source repository. So if you think you don't have enough code experience to do that, I just shared this repository URL with you, the effective GitHub one, which was for this particular session. Make a random code change to it, upload a pull request, and just to show you how pull requests work. So try all of this out for yourself, and you'll have a good understanding of how Git and GitHub works.
All right, then. Well, thanks for everyone who's faithfully watching us here. And we hope that we have had conveyed some interesting content for you.
Yeah,
And that's it. Thank you as well, Rishit, for your patience and for all the hard work you've put into it.
yeah,
And I know that I'm a
that's
very serious person. It's difficult to deal with me. And but that's fine. Anyway, thank you very much. And that's it. And see you all on our next broadcast.
yeah. We'll shortly be tweeting. I'll shortly be tweeting out the slides. Maybe Ricardo will tweet it out too.
Yeah.
Yeah, we'll tweet out the slides. We'll put out the slides we use for this particular workshop in the GitHub repository soon after this.
All right. Thank you, everyone. Bye bye.
Yeah, everyone. Bye.